So, hi guys, hi, this is Pardha Saradhi. So, I'm currently working as a mechanical design engineer, as already sir has said. So, to get further, we'll be discussing about surfacing using CATIA. So, as of this is a demo session, we'll not go into that much deep. We'll see one example how to use that surface designing in CATIA and how to create some components or some parts by using CATIA surface designing. Okay. So after you enter into your CATIA, okay, so after you enter into your CATIA, your workbench will look like this. And if you want to go for any mechanical or any surface sheet metal, here in the start button, you can able to see here mechanical design, part design, assembly design. So whatever, weld designs, mold tool. So in this only we will be having wireframe and surface design and also generative sheet metal. Or else in shape also we will be having generative shape design. So this CATIA software is basically will help us to change our workbenches easily. Okay. So in this CATIA software, it is flexible for us to change from one workbench to other workbench. So let's say if I'm working in surface designing and then I want to immediately change it to part designing, I want to convert that surface into part designing by adding some thickness. So then I will go to mechanical part design and I will add some thickness to the surface which I have created. Okay, so let's go into the surface design workbench. So you all know basically what is surface and what is part and what is sheet metal. So basically these three are divided into three types, are divided by using dimensional thicknesses. Okay, so in surface designing, so if you see a surface which has zero thickness, like it has no thickness, it's just a outline of your design or outline of your product. Okay, so it will have no thickness. So which has no thickness is called a surface, and which has 0.1 to 3 mm thickness or 0.1 to 6 mm thickness, it is called as sheet metal. And 6 mm above it is called as part design. Okay, or a product. Okay, so let's go into surface designing. I'll enter surface, and here you can able to see on the left side, on the right side left corner, you can able to see here you can enter your part name. So whatever name you want, you can enter. Click OK. So after entering into this workbench, you will be able to see some of these toolbars. Some might be over here or over here. You can bring it anywhere. You can place it anywhere, wherever you want, and you can able to manipulate those toolbars also. Okay. Uh, 1 second. I'll just open one simple example, and we will be discussing with that example. See, so this is an hair dryer. Okay, so this is an hair dryer. So let's see how we can able to design this by using our any plastic model. So this is basically plastic model. So any plastic models where we start designing, we need to design in surface only, because these such kind of complex models cannot be done in part modeling. So that's why we use surface modeling, where we can able to create a 3D models and we can able to design. So for that, position sketch. So initially we will draw this guide curve. So first one, reverse edge. So for that, one line is required and then one arc over here. and also one simple arc over here. Okay, now let's define the relations and dimensions. This should be, before defining the relations, let's define the dimensions first, because from here to, and also from here to here it is 50. Horizontal distance will be 50 mm. And from this point to this point, again horizontal, right click, horizontal distance 75. Okay. Now let's give the radiuses. So this is 125. Okay, see here, bottom side here they have given, but both are symmetrical. So this one also typically it will be 125. They missed it. Okay. Now let's define from here to here vertical distance. So it has been divided into four sections. So the first section here they have given mentioned the radiuses. So it is 20 mm. So 20 mm. And this section vertical distance 30 mm. So you need to understand this curves, and then you need to give the dimensions. And again from here to here it is 35 mm. And then from the last one from here to here is 25. One second, it is, okay, there is some relation over here. Now from that 25. Okay. Now let's make this center. So let's, it is moving like this. Okay, linearly it is moving. So total distance from here to here horizontally 70 by 2. Okay. So now the color has been changed into green color. Previously, while we are giving the dimensions or while we are giving the relations, it is in white color. But now after giving all the relations and dimensions, it has been turned into green color, because that represent us that this sketch is fully defined. Okay. Until unless we get this green color, the sketch will not be defined fully. So if it didn't define fully, if you pull it some like this, if you pull it like this, the sketch will move its original position. So you should not able to move that sketch from one place to other place. So we need to fix the initial sketch, okay, in place, and exit. And here you will be having revolve. So not only this way, we can able to do this in different ways also. So profile will be this profile, and axis will be horizontal axis. Now click preview. Okay, so before that, here in revolve, so here angle 1 we have given 180 degrees. Okay, so if you change that angle, like let's say 360, whatever angle you give, it will come like this. So, or else we can able to mirror it also later. So initially I'll keep it 180, and I'll generate this handlebar also. Then I will mirror them. So there are different possible ways to create one particular product. Okay, so now I'll consider my top plane, reverse H, reverse V, click OK. So that I can able to create my sketch accordingly. So now this is my end and this is my starting. Okay. Now I'll project. Oh, no need to project. I'll just simply draw one line over here and make these two parallel to each other and define some length over here. Length here in this figure here they have mentioned 105. 105. Click OK. That's it. Simple. And this side horizontally from here to here 15 they have given. So here you can see this line to this line, it is mentioned 15 Okay, now completed. I'll exit my sketch because this is one guide curve and to create one more guide curve. So now we will be using swap command, sweep. So in sweep with the reference surface, we need uh, with two guide curves, we need one profile and two guide curves. So our profile will be this radius. So this arc will be our profile. Okay, that 17.5 arc will be our profile. Now our guide curves will be this one and this particular one. So here guide curve, when you create a different guide, when you use a sweep function or when you use these guide curves or profiles to generate any any surface, so those guide curves should be in different planes. It can be in same uh, plane, but it should be in different sketches. Okay, so we have created this guide curve in one sketch. See here you can see in specifications tree. So this is one sketch. Okay, and I exited that sketch, and now again I'll take position sketch and top plane I'll consider again reverse H, reverse V, click OK. Now I'll create one more sketch. See, sketch 3 is added over here. Okay, always keep in mind that we need to define our guide curves in different sketches. So here I'll draw one line, construction line, because this line is for reference purpose. And then I'll define it first by giving some distances. So this side, it can be a little bit inside. Okay, because we will trim it later. So it can be a little bit inside. But this side, we will fix this. And I'll give the angle. 82. Here they have mentioned 80. Click OK. Now this is fixed. 1 second. So here to here. That is 35. Now this is fixed. It has turned into green color. So it is fixed. Okay. Now again, we will create some arcs over here. First, we will take one line. This is normal line, not a construction line. There are different lines over here. You can able to explore if you want. And an arc, inside arc. I'll be double clicking this arc to reuse. And again, arc, this time outside. Let it be tangent. So automatically some relations will be coming. So if you want, you can keep. If you don't want, you can change your mouse to uncheck that automatic relations. Okay, inside arc and again outside arc. So that relation I don't want. And again some inside arc. Okay, now we have defined our arcs. Now we will define our dimensions. So from here to this end to this end, right click vertical dimensions. Here they have mentioned it is 20. So this distance they haven't given. Okay, so we can define this distance. Okay, this arc's distance uh, dimension. This point to the center of the arc. Right click vertical, double click on the dimension, and let's say it's 25. Click OK. Now this arc is tangent to this line, this reference line. Make it tangency. In constraint definition box, you will be having these relations, tangency. Now here a little bit fillet is there. So go to fillet, zoom little bit. Double click. R7. Okay, fillet is defined, and it should not be point to point contact. It should be tangency to each other. So just select the two arc by pressing Control and go to constraint definition and select the tangency relationship. Click OK. Now we need to define this arc. So this arc is R6. Here they have mentioned R6. Double click 6. 1 second. Yeah. Now this point and this line make it coincident. So step by step, we are fixing our sketch. Okay. Next dimension again. This arc, let's say it is 4.7, 4.75. Okay. Now again, this is R9. This will be R9. And again, this should be coincident with this construction line. This arc and this arc should be tangents to each other. And also just define this arc as R12. Okay. Now it's just simply take one single line and just extend it. That's it. So now your sketch is fully defined. So you are having one guide core and second guide core also, but you don't have this profile. So to create that profile, so we need to create the profile at over here. So for that, we need these planes. Okay. We need these planes. So without planes, we cannot able to create any sketches. Okay. So for that, we can able to create a plane. Okay. These are coordinate planes that are defaultly given for you. If you want to create a plane, there is a command called plane. You can select that and also normal to curve. So first, this is curve and this is my point. So here you can define your curve and also you can define your point. Click OK. Now again, position sketch, select the plane. So, okay. Now go to arc, and before that, let let us project these two lines. Okay, this we will make it as construction geometry. Just for our reference to fix our sketch. Okay. Now I'll take first point over here, second point somewhere over here. Uncheck the construction relation, and then third point over here. And let's define this arc. Double click 17.5. Okay. Now it's perfect. So let's hide this sketch, hide this plane. Sorry. And then exit simply. So now we can use our sweep command to create this profile. Okay. So here is my profile. Here are my guide curves. I'll directly go to sweep. In sweep, exclip. These sweep are there are 21 sweep commands where we will be using different guide curves profiles. So this is for line, this is for circle or conic, and this is for conic, and this is for circle. So there are different sweep commands. Totally, there are 21 sweep commands in CATIA where you can able to use them and create some profiles. So here in this case, we need with two guide curves. Okay, because we are having two guide curves and one profile. Okay, so this is profile, this is my profile. Okay, and this is my one guide curve one, and second guide curve. This is my second guide curve. Click preview. We will extend this a little bit. Okay. Now let's hide our sketches. This sketch I will hide, and also this sketch I will hide. So now see this one also I'll hide. Okay. I'll hide these also for your reference. Now that sketch is not required. I'll hide these. Okay. See, now it has gone through the surface. This surface has generated into this surface. So for that, we can trim that surface actually. Okay. So here you will be having trim command. So by using trim command, just select the surfaces which you want to trim, and here you can able to see the unwanted material will be removed. If you want to remove the other side, here you can see, click on other side. So then other side material will be removed. Okay, this transparency will be changed when the material is going to remove. If you want to remove the inner side material, just click on the other side. Okay, or else if you want to remove on this particular surface, okay, just click on the other side or previous element. So this element will be removed. Like that, we can able to change whichever element we need to remove, that element we can able to cut and trim it off. Now click OK. So now these both are removed. So now here we are having some fillets. So over here we are having some fillet corner radius 12 mm. So for that, I'll go to shape and generative shape. Okay. So in generative shape, you will be having operations toolbar where you can find this fillet, edge fillet, and you can able to give these edge fillets. So here it is 12 mm, 12 mm. Okay. So 12 mm fillet has been added. So now we will mirror it. Mechanical, and again go to generative shape. Sorry, this is generative sheet metal. Generative shape design. symmetry, this element, reference. So for that, I'll unhide these planes first. Unhide. Okay. Again, symmetry, this element. Okay. And reference plane will be this plane. Now click OK. Now this element and the symmetry element are different parts. Okay. We need to join them. Before joining them, we will close this back end and this end also. We will close it. For that, we will be here we have fill command. So by using fill command, we can able to close these edges. Okay. So again, if you want to close this particular edge, this edge and this edge. Click OK. Now we need to join these elements. So this is other one element, this is one element, this is one element, and this is one element. So we need to join these elements. Unless until you join these elements, we can't able to give the edge fillets over here. See, over here you are having some fillet at the end, R8 fillet you are having. So here you need to give R8. So for that, if I go to shape, generative shape, sorry, we are already in generative shape. For that, edge fillet, and if you select the edge, it is not selecting. See, we can't able to select because these are different elements. So for that, we should join them. So there is a join option called there is an option called join, so that we can select all these elements and click OK. Now everything is joined. Now directly go to edge fillet and select the edges. I'll give backside also. And R8. Okay. Now everything is completed. Now, if you want to convert this particular surface body into a solid body, or by you want to add some thickness to this surface body, because as we discussed, it has no thickness. It has 0 mm thickness. Yes or no? So if you want to convert this into a solid body, go to Start, Mechanical, Part Design. Here you can able to see thicken surface. So if you select the thicken surface and select the entity, whichever you want to add the thickness, you can give your thickness also here. So here they have defined 1 unit uniform wall thickness. Okay. So 1 mm will be your wall thickness. So the arrow mark represents that the material will be adding outside. If you want to reverse it, you can reverse it. And 1 mm zero thickness, 1 mm thickness. Let's click preview and OK. So you can see here material is added. So to see this, just hide this join option, and then simply your surface is converted into a part body. And then if you want to add some color to that, just select on that thickened surface, and over here you can able to change this color also.